Hello, my name is Stefan, and I'm going to talk about how we can build an infrastructure that connects your IoT devices with the backend infrastructure that we're going to make using AWS. So, for this application, we're going to be using AWS IoT Core, which is an AWS service used to manage your IoT devices. You could also use an alternative service like Hive MQ or anything related to Apache. There are different kinds of MQ broker systems, uh, as you can see here. So you could use this, you could use Apache Active MQ, there's Hive MQ, so many stuff. So, but for this, we're going to be using AWS IoT Core, which does abstract much of the complex stuff that we need to build MQTT server, and also it avoids using. It does eliminate the use of code, different kinds of stuff. Whereas if we were to use Hive MQ, we need to establish that server, and also we need to have a system where the devices can connect it to the server, but in order to read the messages from the server, we need to create a code for that, whereas IoT Core eliminates the use of basically makes it much more simpler. It does come with a cost. It does cost you, I think, per million requests sent to IoT Core, so which is quite small. I think it's around $1 per 1 million, but it does add up when you have multiple IoT devices. But if you have just one IoT device, it's pretty much it wouldn't cost you that much. So for this example, we're going to take AGL. AGL, again, this is just speculation. AGL is an energy company that provides electricity to consumers. I have someone working in AGL, and I've talked with them. They said they pretty much use, instead of AWS services, they use Azure, which is the Microsoft version of AWS. So they have their own cloud services. Instead of actually using, we're going to be using Kinesis, AWS Kinesis. They use Kafka, AWS Kafka, which is much different but almost the same principle. They're both there to handle real-time data streams, whereas AGL has their own system. Kafka is open source, so they can run it on their servers. It's much more cheaper that way, but it's much more complex because you have to manage the infrastructure and all. So we're gonna build this. So application for AGL would be where AGL wants to read a customer's electricity bill. So most of the electricity bills that we get, not a lot of people actually come to your doorstep and check the meter. How it works is there's actually an IoT device or a system or an embedded system that actually reports or sends information through the cloud, so that people at AGL has a system to analyze those data records, and then it'll probably format the data in a form that's readable to users, or uh, somehow like that. So basically, this is all automated. Not probably years ago, people would come to your doorstep, check your meter. It does happen sometimes, but with AGL, they do much of the readings, much of the remote readings. If a connection's active, if a connection's not working properly, they can all detect it using IoT devices, which then sends it to, for example, the MQ server, the MQTT, which is the protocol that we use. MQTT is different from HTTP. It's more suitable for IoT devices because I think it's much, there's less overheads. There are less overheads compared to HTTP, and it's much simpler, faster, and it does not consume much power compared to HTTP. And but the issue with MQTT is that it's not that secure, but AWS IoT handles that security for you, because it does. Again, this is another thing about AWS IoT. They use certificates. They ensure that the connection is secure, and it only accepts give me 1 second. Yeah, so they manage all the certificates and all of that. So again, AWS IoT is a AWS managed service, which is very secure when you're establishing IoT and when you want to make a system uh, to read your IoT device metrics or anything. I also could think that you could use this in like Telstra. Again, this is speculation. They probably have Telstra sensors. So they probably have sensors at different places where for each towers maybe probably to read performance, probably to see if the uptime to see the uptime of a tower if it's working. So these are all stuff like even big companies probably use to make sure that the readings are then processed and they're formatted and then handled properly. Because with AWS IoT, you also can perform specific tasks, like you can have conditions, like to maybe call a different function, maybe to alarm a system. These are all stuff with AWS IoT. So we're gonna get started with this. We're gonna connect a device. That's how it works. And again, this is just the endpoint. So this is the endpoint where in other words, where your IoT device is going to be connecting to. This is like it's going to be communicating with this endpoint. We're not going to be using an IoT device like an actual like microcontroller. While I'm planning to do that later on, you could also use this in an ESP8266. It uses the same principle, but the coding is a bit different. Instead of while AWS IoT is mostly focused on deploying it on Windows or Mac OS, you could also use the same principles to deploy it onto a microcontroller like the ESP8266. It's a bit different. You need to fetch each certificate directly, which I'll show you afterwards. And there's actually another video on YouTube that discusses how you can write the code for the ESP microcontroller to communicate with that endpoint by passing the relevant certifications and all. So then once you go with that, just next, you could ping it. You could just go to your endpoint. Maybe you can go to the endpoint, copy, call out CMD, just to see if it's working. It's just a test that we do to see if it's pinging, it works well. That's pretty much it. That shows that it's working. Then we can create a thing. So in AWS IoT, we call an item or maybe a sensor a thing, and you can actually categorize it with additional configurations by grouping it. So for example, you have a group of electric sensors, and then you can have a group as electric sensors, and then one sensor could be sensor 1, sensor 2, like that. And these are just for making it easier because it categorizes for billing and also for searching, because some businesses could have thousands, maybe sometimes millions of sensors. So then we'll go thing name. Again, most of the time this is not created by hand because it would take a long time for us to create 1,000 sensors for every device. So most of the time this is automated with CloudFormation, sorry, or Terraform. But I'm just gonna run this using let me see, let's call this a device, just to be simple, device. And then it's going to tell us which platform you're going to be deploying it. So for this experiment, we're just going to deploy an application where it reads the CPU and the memory usage of my laptop, and it's going to pass it on to AWS IoT Core, which then can be processed. So I'm going to do Windows 10. We're going to use Node.js as the runtime, and also for writing the code we probably have to use JavaScript. And again, these are just what it means is this is going to provide you with a starting code as well to test your thing. And then it's going to ask you to download it. So we're going to download the kit, which basically means it's going to give you the relevant certifications, the keys and all. And once you go there, you'll get this device. We'll extract this. We'll call this IoT, and then we'll extract it there. So it's going to be extracted in IoT, as you can see, and it's going to have a PowerShell. So we're not going to be running this using CMD, so make sure to close CMD and open up PowerShell. Yeah, and what it basically does is, now we're just gonna, we already extracted it. Now we're gonna run this command. So that's why it makes it much more easier. This is only suitable for Windows and macOS because it does help. It does help you start with the code. So PowerShell, you copy paste it, and then oops, no, you need to go to that cd IoT, and let's paste it again. And you're gonna basically run the script, the Windows PowerShell script. I'm gonna show you. So what it's gonna do is, it's gonna be, let's open it up. You can open this with, hopefully with Visual Studio. Yeah. So what it does is, it's basically gonna make sure if the certificate is available. If it's not, it's going to be downloading it from this URL that's provided, which shows that it can communicate with this with Amazon. Basically, it's authenticating that it's from Amazon. Then it's going to make sure if this folder is not there, which is basically a GitHub repo directory, which has sample files to test out. It's basically a project which is provided by AWS, and then it's going to clone that, and then it's going to open it, then it's going to install the relevant node modules, and then it's going to go to this directory, and then basically again install it. And then what it's going to do is, it's going to run a JavaScript. It's using it's written in TypeScript, but it's using the JS, which basically is going to say that I want to run this node, run this, and it's going to provide arguments, which basically that application is going to be accessing these arguments, which means the endpoint, which means what's the URL we want to communicate with, the certificate that's passed, and all of that, and the client ID, which technically means that we want to accept it only if it's, and we can actually secure this by handling or by implementing policies. So we only want to handle from this, and then we can have st test.js, which means that I want to call a topic. So how MQTT works is, it's using a pub sub method. Basically, you're gonna be the device is going to be sending it to this topic, and then from that it's going to be sending it to subscription. Very similar to how SNS works, but it's converted to a Mosquito protocol. So we can just, once we ran it, it's probably gonna run this. So what it's gonna do is, it's gonna run that application, and it's gonna communicate with that device normally, and it's gonna show it if it receives any messages to this to this topic. And it does take time. It's gonna run, and then it's gonna run it. Yeah, so you can see it's actually sending messages, and I'm getting messages. So this is showing that it's actually communicating with the basically AWS IoT core correctly. And then after that, you can just do connect next, And that's pretty much it when it comes to creating a stuff. So we pretty much got the device running, but we don't want to use the standard code, or we don't want to use the same topic. Basically how topics work is you can just define a topic on the go. So, and it doesn't have, like, we don't have anything to do, like we don't need to configure anything, we don't need to create a topic here in AWS IoT core. We can just create a topic here on the go. So just define a topic. How we actually accept whether a topic is recognized is by using secure policies. So I'm just going to show that to you, and I'm just going to take a break now. Yeah, so I'm going to talk about the application itself that the PowerShell script is calling. So basically it's calling this directory, and I'm just open it up. This is just a distribution of the production file, so we don't really look at this because it's going to be very cryptic. We're going to see the application that's written in TypeScript. What it does is it's going to use the MQTT protocol from the AWS SDK for IoT devices, and then it's going to call up some other functions. It's also going to pass some the arguments as shown here, and then it's going to create a connection. It's going to first create a request, and then the hello world is not actually visible, like shown here, because it's using common args. You have to go to the CLI. I can show you, because let me just, I mean, it's organized in a very different way because everything is interlinked. Let me go to util. Yeah, should be around here. CLI arg. It should have hello world. Let's just put hello world. Yeah, as you can see, there's a message called hello world, so it's going to be calling this. Again, you don't need to make it that advanced because they're using they're making sure they use different modules, different files for structuring. But what it does is it's going to be calling this function. It's going to be sending a message, and for each, this is the message that's going to be sent. So this is the message, the arg.message, which is fetched from utils, and then it's going to give a sequence number for every message that's sent. And there's also there's a different timeouts as well. I think that's to make sure that it's constant, shown here. And then it's gonna, if the request or if the push was unsuccessful, it will show a reject error. And then we want to handle it if it gets rejected, we want to make sure to handle it in a different way. So reject, yeah. And then we also have, this is the main program, so this is what's being called out, and also this is the whole application, and this is going to be calling out these functions as well. And there's also clear timeout if for example after some time we wanted to close the application. Very simple application. It looks very cryptic because there's so many things going on, but I've actually changed it a bit. Not really a bit, I just created a new file. Basically it reads CPU metrics and memory messages. I got it from a different source, so this is not my script, but oops, let me pull this up. Yeah, so basically what it's going to do is it's going to get the OS so that you can access the operating system metrics like CPU and all. Again, it uses the MQTT protocol, and it's going to get the required arguments because to establish that connection, and it's also using the client ID. If it's not provided, we're going to generate one. We don't want to do that actually, but then again, we could, but then what we have to do is we have to make sure when you're putting the client ID, we have to put an asterisk. That's why anything after this is accepted, or else we can just go with the arguments provided. And this is the interval. We want to make sure to, if it's not provided, we want to make sure that it's sent every 5,000. And this is going to get the CPU stuff. This is going to get the message, which is going to be showing CPU, memory, uptime, and the timestamp. So that's going to be the message that's going to be pushed using MQTT. And then this is basically the class that's going to be handling the connection. It's going to initialize the connection. It's then going to connect with it. It's going to start publishing it every 5 seconds and so on. Again, what we're gonna do is since AWS has provided us an application with all the dependencies and the node project, we're just going to use the same thing, and we are going to go to pub and sub, and we'll copy paste that monitor here. We'll paste it here, and then we're going to run it. So to run this, we're not going to change much of the stuff. We're just going to change the file. So what we're doing is we're calling this script, so we need to change that as well. So to change that, we'll go to our script. We'll call this. Then we change the location of our thing to monitor.js, and put the same endpoint, certificate, and same topic for now. And let's save this. Yeah, and then let's run this. So it says it's connected. It's perfectly connected, and then if it's publishing it, it should see, it says it's publishing. It's showing my the average usage. I have no idea what this is, but this is part of the script. It shows how many cores I have, and it shows that I'm using 35. I don't think it's accurate, to be honest. Let's just check it out. If it is accurate, that's pretty cool, but I don't think that's going to be accurate. 42%. I don't think it's that accurate, to be honest. So it is sending it through in JSON format. It looks like it's not correct. Yeah, again, these are just random figures. I don't know why it's not working, but the application's trying to understand that. It's trying to understand this is the CPU reading, this is the memory usage, and it's sending it to the system. Let's see if we can get that. And to test it out, we go to a thing called MQTT test client. Or we can just go to the devices. Actually, let me just show you that instead. We'll go to devices, to our things. Then we press on this. Let's press on this, and then we do activity, and then MQTT, because it automatically connects it for us. Let's see, we should be, and then we have to subscribe to that to receive the messages. Because we are acting like an endpoint now. So we'll call this, we'll put the same topic here, and then subscribe. So as you can see, now you're getting messages. See, by every 5 seconds you're going to get a new message. It's changing with the timestamp. The timestamp's also here as well. But as you can see, let me just delete all other topics. Yeah, so it's just reading the messages. It's just subscribed to this topic, so that any message that's sent to this topic, I can see it right now. So it's basically retrieving it every 5 seconds, as you can see. But we don't want to use this topic. We want to use a different topic. So we're going to change that a bit, and let's end the program for now. Just control. Yeah, disconnected, everything. Yeah, then we are going to run a new topic instead. We don't have to do anything here. We don't need to create a new topic or anything, but what we have to do is we have to go to a thing called policies. So we'll go to a thing called policies, and we'll just delete this because they're no longer needed. So we'll go to the policy. So by default, there's a policy made for this. What it's going to do is it's going to accept the topic that was there before, which is SDK or whatever that was. So as you can see, you have, these are the stuff that are allowed technically. So it allows publishing or sending information to this topic. It allows receiving from this topic. Basically an idea of the fact that these are basically the access policies for this device. We're going to change it a bit, and we can edit the version. There are different, basically when you create a new version, you're gonna be, when you edit it, you're gonna be creating a new version, and then you need to set that as default. So we're gonna go to JSON, and so we have this stuff, and we also have subscribe. So we're just gonna remove these stuff. We're gonna remove here, and then we're gonna add a topic call. Stefan readings. So I will say Stefan's laptop. So whenever it's sending it to this topic, it basically means that I'm sending my laptop's readings to this topic. And so when I'm subscribed to this, I'm going to get any information related to that. And then I'm going to just make sure I use that instead. A topic filter means that I just it's just instead of hard coding it, it's just directly putting a topic filter means it's like a wildcard. And this is the client. So the client is kind of important. What it means that you're going to be so it's kind of like a secure way to say that, you know, basically you're going to be giving, as you can see here, a client ID, which is basically this. But if you want to have another, like say for example a username or a specific ID, a digit or a code, you can just literally put it here. But we're going to go with the default, or we can just call it, let's say it's Stefan, and we are going to say here Stefan. The reason why we do Stefan, as you can see, that wildcard is because anything after this dash is acceptable. So v2, v3, v4, anything. But we're just going to keep it same so that we only accept one. If you want to accept anything, just put a star there instead of anything else. So we'll put here Stefan, so it only accepts from Stefan. And we have to set the edited version as the active one. And we're going to save it. Let's see. It should be quite soon. And then what we're going to do is, so it's going to show you this is the new rules, this is active. Now we're going to change it, and if you try to, like for example, send it now without changing anything, it's going to say connection fail. See, because we don't have the policy for this topic. But now we're going to change this to, we're going to change it to Stefan laptop, as this is the topic that we want to communicate, and run it. This should work. Connected. You can see it's connected, no issues, and it's going to start sending information. So that works. But now, for example, what if I put a different client ID? Say, put something after for Stefan, and it's going to say rejected. So these are the protocols that we use to make sure, you know, this client is sending it to my AWS IoT core. It's sending it to the correct topics. I only allow you to send it to correct topics. Again, you have the control of choosing. AWS IoT core provides you with an interface to do this, but if you were to do it with MQ or another broker system or a broker server, it's going to be much harder. You need to configure a lot of things, and so that's pretty much it. So basically, when it comes to reading, it's going to be reading, but we don't want to read on this MQTT client, test client. We want to make sure it goes to a different service, or we want to stream this or direct this to a different service. There's so many other services which I can't cover everything. Before I move out, I just want to show, I just want to also talk about some stuff I've discussed about this categorizing and all. Fleet metrics, I think it's going to be removed by AWS soon. Let me just check, because as I remember, AWS services will not be supporting this anytime. Yeah, so it'll be discontinuing from October 18. If you want to know about it, if you want to learn it, remember that this is going to be useless after October 28. So you don't really need to know about that. Software stuff. Greengrass is so instead of it's a very similar to AWS what we're doing right now, but instead of having it on Windows or macOS, you can download the Greengrass software. So they have a software which you install on the IoT device, which is more specialized because it does handle you to do certain stuff. Using that software, you can do some edge computing on that software before actually sending it to the AWS IoT core. So it does eliminate the use of actually sending it to cloud, because say for example you want a system like you want a sensor on a system that detects, say for example, the pH level of soil, and instead of actually sending request all the time to AWS IoT core every second or every 5 seconds. Without doing that, you can actually do some edge computing, some processing on using that Greengrass software on the IoT's end. Check whether the pH level is above a certain level. If it's not, you want it to not communicate with the cloud, not send any messages. But if it is, you want to send a message. So again, it helps specialize in IoT stuff. But you also could avoid using Greengrass. It's not really needed, because I have done the fact that you can just do simple processing using C++ on Arduino or Arduino language. Basically, they support those are the languages supported on ESP8266. You can do some basic processing on the microchips before actually communicating using like if conditions and all. But if an application is too small and you want to just simplify that, you just could use Greengrass. It's basically they have their own devices which is specialized. We're not going to focus on that though. There's also another thing called IoT tunnel. A secure tunnel, I think. Basically, if I want to, now say for example, I have established a connection with I'm establishing a connection with my Windows and AWS. I could literally, in other words, SSH into my Windows. So it's basically creating a secure tunnel into my Windows device for some time. It's actually, I think, 12 hours or something, but it does cost you a lot. I think it's per session. So for 12 hours a session maximum, it's around $1 or something. And so that's pretty much it when it comes to AWS IoT Core. But I'm going to show you how you can direct it, and that's actually to do with let me see, it should be message routing, as you can see. So we have a thing called rules. Destinations is very similar to rules, but destinations are used when AWS IoT does not support that particular destination or that particular service. For example, you want to direct that message to a different endpoint, say another website, or you're using, say for example, another third-party software which is monitoring levels, and you want to send it through HTTPS. So that is like basically you're going to be creating the destination. You're going to be saying, okay, I want to send all my data to this URL. So again, this is only used for if you have a service out of AWS, or it's something that's not something that's not supported by AWS IoT Core. But you could definitely use rules. So I'm going to show you how to use rules. So we're going to create a rule. I've already created one. Let's just delete this. And we're going to create a rule for this, and we'll say notify, or let's say read metrics. You just want to read metrics, and let's say I want to read my laptop metrics. A very simple thing. Yeah, and then we go to next. You can keep text. What we're gonna do is we're gonna say, okay, we're gonna check our message that we're gonna be sending. We are sending CPU, so we want to get the CPU. Oh no, let's say we want to get memory. or whatever we want. We can get multiple if you want. We'll say we want to get CPU. This is using SQL, very similar to SQL. CPU, you want to get CPU, and you want to get memory. And what is we'll go with timestamp. We don't need everything, we just need some certain data. Like we only need specific data, so we're basically doing some form of filtering here, and we're only sending the required one. And this topic means that, what's the topic? So we are actually sending it to Stefan, and we're supposed to put this, and there's an example given here, so you can always check here. So we'll say Stefan and laptop. And there's also a condition. Again, this is if you want to make it have a condition. If you just want to retrieve all the logs, so all the messages sent, basically all the messages sent to this topic, and just subscribe to all the messages, you just leave it like that. But if you want a condition, so for example, where timestamp is after a certain time, or if you want to say if memory is about this specific time, because then I want to make sure I alarm a system, something like that. We're not gonna do that for this. Just gonna next, and we're just gonna show the destination. So to show you where I can send it, you can actually send it to Kinesis data stream. This would cost you money, and data streams are, I think, quite expensive. I mean, for me it's quite expensive, but just for the sake of this, we're just gonna use CloudWatch. We're just gonna create a group. We'll create a group. There's some other stuff going on. We'll create a group. We'll call this Stefan's laptop. So basically it's a group of logs. We're creating a group of logs, or a log space, where we can retrieve logs. Remember, this is all real-time, even though CloudWatch isn't a real-time service. IoT directly sends it to your destination, so it's quite fast. Let me create a log group, and we'll call this Stefan's laptop. We'll expire this one day, so it won't. Basically, all the logs will go out. Again, you can keep this as much, however time you want, or whatever you want. This does use, I think, S3 buckets, so it's important to remember that. And then we'll create it. Then we're just going to use that as our log group. We're gonna ignore that. I'm gonna go with the IAM role. We don't really need an IAM role to access the CloudWatch, but if you're gonna access, say, for example, Kinesis, there's a Kinesis. I think there is no role for that. We need to create a role for that if we are using Kinesis, because the IoT needs to communicate with the Kinesis data stream. But for this, it's okay. We'll just say next. Oops. Or maybe, oh, it still needs for CloudWatch. I'm sorry, I think I got that wrong. You still it really doesn't mean you're just attaching a role to this, so it doesn't really have all that stuff. When you just create a new role, you're just attaching a IAM role to this AWS IoT service, or this rule. It does not mean that it has all the required permissions, but yeah, if you wanna, you still need a Kinesis role. You just create a Kinesis role, and then you go to IAM role, and then attach the relevant policies. So we have CloudWatch, or you can just create a new one, and it doesn't really ask you what permissions you need yet, because CloudWatch, to communicate with CloudWatch, you don't really need one. But yeah, CloudWatch is okay, and then we create it, and then we can go to log groups, and we'll go to our newly created log group, and so it says read metrics, it's active, so that's perfect. We'll start a thing now and see if we can get information, or basically if the logs are sent to the correct group. So start tailing. Basically, this is a live tail. and it shows that we got our first one is showing you all the requests. It should be every 5 seconds, so let's count it. 1, 2, 3, 4, 5. See, it's quite fast. Basically, it's going to be sent on regular intervals. You can open this up to see all the data. Most of the time, we don't use CloudWatch for this. You could use CloudWatch and store it in S3 buckets and then use Athena. I wouldn't recommend that. Usually, what we do is we have AWS Kinesis, Firehose. Most of the time, we use Firehose for this, and then we directly, if real time is important, we'll just stop this for now. If you want real time, you're probably going to use data streams, Kinesis, which I'm going to show you now soon after my break. But basically, Kinesis is if you want real time data and if you want data retentions. Those are the two things that you need to remember when it comes to differentiating Kinesis data streams and analytics. So basically, Firehose is needed also when you're sending it from Kinesis to your data warehouse, but you could potentially use a Lambda function to pull messages from the data stream Kinesis and then dump it into a Redshift cluster or S3 bucket. So again, there are so many ways that you can approach this. Really, if real time is not really needed, if you don't want to get the absolute the latest measurements or instrumentations, you could always go with Firehose and then directly push it to a Redshift cluster. And if retention is not that needed, if you don't want to retain, if you don't want to go to a point in time to retrieve that certain data, then Firehose is the best. But again, that's something you need to remember. But if you're going to use data streams, you need to use Firehose and data streams, or data streams with with a Lambda function, there's so many ways to do this. So I'm just gonna discuss how you can connect Kinesis streams, and then from there we'll look how we can approach this